So, yeah, I changed the name a little bit, last minute. Sorry, guys. Yeah, so now it's, what I want to talk about is building composable apps, but also crypto apps on Urbit. So it's going to talk a little bit about a few things we're doing. One of them is this data composability agent database called Bedrock, and this crypto identity system that's supposed to make it easier to do like any crypto-related apps on Urbit. And then I'm going to give you a little preview of what we're doing with Realm next. So to start with data composability, I want to explain a little bit about our experiences of building on Urbit so far and trying to build a composable apps. And so to start, I'll kind of walk through this overview of a Web 2 model of integrating different APIs and things. So to start, like, you want to get a balance from a third-party API. I don't know, maybe it's Alchemy and you're trying to get the balance for your ETH wallet or something like that. But usually these things come in their version, right? And I think we just had a talk before this about versioning, so I'm sure that's going to help. But from our experience thus far, really what we've realized is in the Urbit case, it's effectively the same when you're communicating between two agents in that if I want to integrate with the ETH wallet, which is a third-party developer, then I have this dependency I have to manage, right? So if they update a type or they update some state that they're storing, then I have to be aware of that before they push the update, or else my app breaks in different ways. And so we figured this out because we had done all of these bounties at the beginning of the year when we launched the first version of Realm. And we had all these guys building apps on our agents, and we had spaces and all these different things that we wanted them to integrate. And then we were like, we need to update something. So we would do an update, and then all of these apps would break. And we were like, OK, so this is not great. And then we had integrated with groups, and if they push an upgrade to like chat or groups or change something in the way that their types were set up, then our scribes started to break, and different integrations would break, and then we would be confused for a minute and be like, well, what's going on? And then we'd figure it out, and then we'd go and update and stuff. But so right now, like within the ecosystem, this is like fairly early, and it's OK to have these sorts of growing pains. And so what we wanted to do is figure out like, how can we make this easier for developers? And it's not just about like integrating with different apps. It's about discovering the data you can work with, right? So in this example here, this is sort of our solution to this problem, where the third-party dev who writes the ETH wallet would actually integrate with Bedrock, and they would, instead of storing state in their own bespoke structure, they would actually store it in Bedrock. And then my agent would just read that data out of Bedrock, and I can get into a few of these points, but the goal is that we have data that's addressable by a unique path. So it's you can scry it, use it for remote scries. And this is an example of it, right? So like I have a table, notes at it, v0. So everything's version. So you can imagine all data types that are stored in Bedrock have a version number with them, right? So if I build against version 0 and they upgrade to a new version of the notes edit table, then I would get, it wouldn't break, because version 0 will still work, because part of the system that we're trying to build with Bedrock is the forwards and backward upgrades, so that data from version 0 can still work. And when it goes to version 1, you can take your time to upgrade if you need to. But this sort of helps when you get to things like, if you want to build an app, like a quick little app that you want people to build on, and then you don't really think about it for a while, and you come back to it, it could just totally have been broken, and you weren't aware of that until like people were messaging you like, hey, the thing I was using is now broken, right? So this hopefully would help solve that problem a little bit. The other thing is that there's this common pattern you do when you're building an agent where it's like, OK, I've got the state I want to send to all these peers, so I'm going to manage a peer list. I'm going to say, here here's how I want to sync that. And every time you build an agent, you effectively have to build a new sort of like way to do this, over and over again. So the thought here is that we'll actually make it all based on paths and have every path have their own peer list, right? And so we have a few strategies for this. Like we have single host, shared host, and gossip. To date, in the current version of Bedrock that's out there, we only have the host version for the replication and syncing strategy, but we're working on the other ones over time. The next point that's really important is, versioned. And then the fourth one is automatically syncing to a client database. So this is another thing that we had a challenge with, was more so like, okay, so every time we make a new agent, we have to integrate that with our UI, and there's like a lot of work to be done to like make sure everything's syncing properly and whatnot. So we thought, well, what if we just synced Bedrock itself to a local SQL database so that the UI could just query out whatever data they wanted, and you could join across apps and aggregate things in a view where you don't necessarily need an agent, but like, oh, I want to show a calendar event, with this, I don't know, other thing that's going on, maybe a talk. There's like, I'm listing all of the conference, or I make an agent for Reassembly or something, or like a conference agent, and I want to like reference a calendar event, right? Being able to do that without having to like, go off and scour Urbit and DM people, or like see who's the developer of the calendar app is, and be like, hey, can you like walk me through this? Our solution is more so like, you would actually scry Bedrock's type path, and it would return back all of the data types available for you to build on in Bedrock. So that's essentially what the solution is. And so to clarify a little bit, paths, like what are paths and what are the types and what are the tables and what does all this mean, right? So the way that this works is that a path is not a table, but a path is like a pointer to a set of data primitives that would be synced on that path. So in this case, this is a very simple example, and this is actually currently working in the latest version of Realm, where we just totally replaced lexicon. Instead of having it be a bespoke agent, we converted it into Bedrock as like a first test to see how it would work. And effectively, in Bedrock, it's stored as if it's a series of like flat tables. And we're working on having a way to dynamically like display that in a structured type. But for now, it's kind of like a little bit raw. And I've actually was talking with Ted the other day, and he mentioned, what was it, Ulam. Yeah, something that he's working on that could make it a lot easier. So I don't have a lot of details on that, but if you want to know about Ulam, he's the guy to ask. So this is an example of lexicon, right? So you've got your word, you've got a series of definitions, so you might have multiple ones per word, and you've got your sentences, right? So the cool thing with this is that this data just syncs magically to the UI because we've built this JS, lib for Bedrock, and effectively it syncs the entire state from Bedrock to the tables on the client side, right? So then you just, you only have to use this, and pretty much any app that you want to build just would work, in building a simple UI. So supported column types. The way that we built it so far is that you can essentially use like any atom for the value, but when it comes to like more complex types, we've restricted it for now to be more so like a list is a list of strings, sets a set of strings or t's, and same thing for maps. But outside of that, you can essentially store for every column any type you want. So this is really the core value of building on Bedrock, and it's something that as we migrate pretty much we're migrating all of the things we built on Realm onto Bedrock, and this is going to be the most valuable reason to do that, because now you have all these common types that you can associate with any data element, any row of data. So you can have votes, ratings, comments, tags. We have the concept of following, so you can follow a specific path that someone's, hosting. Maybe it's like, I don't know, their meme repository or something like that. So you could follow different paths from different people. And the last one is the most exciting one to me, and I think it's going to be the most powerful thing in Bedrock, which is the ability to retweet any row and we just call it relaying. So really, the way that it works is like relay objects are they're kind of like C pointers in that the only way, you have to remote scry them to get them dereferenced. And this is like an example going through how it would work, right? So imagine in group chat 1, there's Zod and Bus, and then group 2 has Zod and Fed. Although, I don't know. I don't think I'd relay things to Fed personally, but let's just say Bus wanted to Fed post or something, and he forwards a message from group chat 1 to group chat 2. Effectively, the way it works is that Zod, he creates a relay in group chat 2, pointing to the object in group chat 1, but he also publishes that the version of data that was in group chat 1 and hosts it on his own remote scry namespace. So the burden's not on the original poster, the burden's on the person who relays the message. And so Fed sees that the new relay row is in group chat 2, and he goes and calls the rest of his FBI buddies. And he follows the link and pulls the data and sees a meme that's spicy, and then he logs it for his superiors. And so here's a visual example of how that would work. So in this case, this is the original group chat, right? In Bus, there's a message there. And so what happens when Zod wants to relay that to the other path is he publishes in the relay table a reference to the ID. And this is simplified because if we wanted to write all the paths out, it wouldn't fit on the screen. So he puts a reference back to the original path so that here in the group chat 2 path table, we have this as the content type is relay. So what happens here is when you see a relay type, you go up to the relay table and you see, okay, what is the ID? Who has posted this relay? And then you remote scry the original contents. And then what happens to all the peers on group chat 2 is that they'll actually create a path for group chat 1 that just stores that single message. So that way everything is sort of addressable, and there's no weird kind of hacky things in there. So you can actually relay multiple times, multiple people can relay, but because of the way the relay table works, and it's a unique ID, if you have 10 people that relay the same message, you only ever get one copy of it pulled to the other peers. So that's the relaying functionality. And for us, we're using this for forwarded messages, but you could also use it for lexicon, right? So if you're in one group or space and you want to forward it a hilarious word to another one, you just could relay that from one path to another, and it just magically syncs over. So the idea here is not only data composability when you develop, but having data just pass around. And obviously there are permissions, you can restrict shareability of certain paths and things like that, but generally it's cool if you want to build something social to be able to reshare it across paths. And so what's still to come for Bedrock? So everything that I kind of described there is currently out there. We've been tweeting about it a little bit. We have docs up there. We have our Git repo for the agents is now open, so you can go and check it out. But what we're doing now is we're working on the data type scry, because really the goal of this is to make discovering the data primitives easy, right? So we're working on a calendar app right now, and we want people to be able to download the calendar app. They would then be able to scry the type scry, and it would return, here is the data primitives for calendar, which might be the calendar object, it might be the calendar events, might be time zone related things. All of these things are now listed, and you can then, instead of going and writing your own backend for a calendar, you just leverage that, right? And you can write to it and pull from it, and if you wanted to add a calendar event from an app for whatever reason, maybe it's in your group chat you just are hey, let's schedule a meeting. You could just write straight from the group chat app or whatever you're building into the calendar table or type, and then just it would appear on your calendar, right? So that's the goal of this, is so that people can discover the primitives, so you're not just rebuilding them over and over and over again, right? So we're going to do the other replication strategies, which are shared host and gossip. And the last one is the adding a new common type, which is going to be all of our chat data that we have now. We want to make it Bedrock friendly. So we're going to actually migrate everything from our bespoke chat agent into Bedrock. So that means that anyone could write, if they want to do a chatbot, if they wanted to write their own features into chat or pull our chats in and then add stuff to it, you'd be able to do that. And hopefully, in doing all of this, we could probably come up with a way we could share maybe some UI code so we can share these cool new features that we add, right? So yeah, if you want to contribute, we are now that the repo is open, we're actually looking for people who would want to work with us, because the goal of this is to get other developers, to help us build it out, use it, so that we can build this more composable, discoverable, data layer. So yeah, the second one is crypto identity primitives, and this is the one that I'm the most excited about. The Bedrock thing is something that we kind of need as a foundational piece to make just our development better, but also to help more coordination amongst different people and players in the ecosystem. But this one is also going to be one of these open primitives that we're going to build into Bedrock. So really what this is all about making the Urbit ID the root identity, and then being able to associate a lot of different addresses, perhaps, and aggregating NFTs underneath a PAT-P, and then obviously having a little social profile on that as well. So what does this look like? This is a design of what we're building currently for mobile, but effectively what you can see here is that I've got my default. This is my default address. So if you want to send me anything, you can look at my profile, see that, tap it, and pop over to Wallet Connect or through Wallet Connect to MetaMask or anything else, and send me something, right? These addresses here effectively are you sign a message stating that lomder-librun owns this address with the private key from that address. So when you add these addresses, you pop out to MetaMask or Rainbow. It prompts you to sign, and then you sign, and then you can add this to your account. And the thing with Passport is that you can do a lot with that, right? You can start doing things token gating a chat, right? You can token gate chats or any feature that you want to token gate. And this is one thing that we're doing right now to build it out. But the goal for this is that because it's built on Bedrock, because it's more of a more open primitive, anyone could start doing more crypto things on Urbit. Because effectively, what our vision is moving forward, or what we're focused on in the next year probably, is going to be just leaning heavily into the crypto narrative, right? And I'll give you some examples of that in a minute. But yeah, Passport's going to be an open primitive for everyone to build on. Right now, we're still in the process of building it all out, but we're still looking for people that are interested to chime in, to help out, to help put in PRs and ideas. And yeah, so what's next for Realm? Like I was saying, it's all about crypto. And for us, it's about mobile and crypto. So one thing that we're building is crypto login, right? So what does this mean? How do you log in to your Urbit with a wallet address? In this case, we're doing it through our hosting platform. And usually you log in with email and password, but we want to make that more crypto native. And so now you can sign in with Ethereum, and you can actually pay for hosting with Ethereum, or eventually we'll support USDC and things. And yeah, you just connect to the wallet, you sign a message, and then you're logged into chat, right? It's pretty straightforward. And yeah, like I was saying, crypto payments for hosting. So this just allows people that are more crypto native, or people that have a lot of crypto, to actually pay for some actual service with their crypto, right? So I think this is going to be really exciting moving forward. So I guess the last bit of this is we do have a public test flight link for the mobile app. So as we continue to build out these crypto features, if you want, just go to tinyurl/RealmIOS. You can hop on, and you can start playing around with it. So that is like the big overview. And I think there was one more slide, but I don't know where it went. But it just says questions. So if anyone has any questions or, yeah?
I've never seen the word scry before, so I looked it up. Under scry.cloud, I found scry is using emergent research on cognition and decision-making to turn the art of predicting the future into a learnable quantitative discipline. Can you explain, elaborate on that in your context?
Yes. I don't know. Is that in the docs? I don't know. No, I would say a scry is effectively the way in which Urbit describes a GET request, is the simplest way to put it. Like
Does what?
a GET request, so like when you call an API and get a response, that's sort of what a scry is in the Urbit context.
Okay.
Yeah.
Like a REST HTTP GET request.
Yeah, unrelated to that.
It's a way of reading data.
Yeah.
Okay.
Yeah, reading data.
Okay.
That's it. Anyone else?
Could you guys use the microphone so that we can Thank you.
Where's the microphone?
So will bedrock values be bound in the scry namespace? How exactly will that work? Will they be referentially transparent? Anything that goes in there? Can we make that decision as a
Yeah.
developer?
Currently, currently it's limited. So I would be happy to talk about, making sure we support those things. It currently just effectively is the types that we have set for the column types. That's effectively the response. So it's all based on the types that are baked into Bedrock so far.
Yeah. Let's say someone has an alternative implementation for chat message or follow, right? Like, are either of those that you guys have already put in Bedrock the de facto implementation for those things? Or how would you kind of find or choose whichever implementation you want?
Yeah, I mean, so the ones that we have there are just kind of like there as defaults. It's ones that we think are useful and that are simple. But if there are other ones that are built into Bedrock, like effectively what it would be is you would have to install an app that has, like that's implemented that follow primitive. And maybe it's called like, I don't know, whatever you want to call it. Like maybe it's called, your app follow or something like that, whatever the name of your app is. But effectively with the discovery scry, where you can just like scry for all the types, you'd be able to see that, okay, there's actually different implementations of follow. And the goal for building out that scry and leveraging the sort of dynamics type system that Ted has been working on, I think the goal is that you could actually see exactly what those different types do, how they're structured, and you can make the decision of what do you want to use, right? So it's not like exclusive to just those common types. It's just we wanted to put something out there to start, making these sorts of features work on Urbit, right? So if you have a better implementation or a more robust implementation, maybe we could make a new version of the follow and leverage like the more advanced version that is more useful. So we'd be open to doing that as well.
Yeah, we're actually like working on like a versioning system for like types and whatnot. So it would be good to like talk about that. Yeah.
Oh, for sure.
Yeah.
So I think for Realm, you guys thought about putting in the client this MySQL database to pull from. Have you thought about putting an Urbit Moon like into the Realm client and having that be what you're kind of accessing more locally from the client side?
I mean, it's something that I think in conversations we brought up, or some people have thrown the idea at us, but we haven't explored it really yet. But that could be an alternative. I think it'd be more interesting to, maybe just having it be like a background service on your computer that any app could read from that is leveraging your Urbit data.
Any other questions? No? Let's give it up for lomder-librun, everybody.